Hello and welcome to the Chapter 5 podcast on Section 5.1. Today we're going to discuss the basics of energy as it relates to thermochemistry. So thermochemistry is heat related to basic chemistry functions. We'll actually revisit energy again later under the guise of thermodynamics. So try not to confuse the two for now. Thermochemistry is basically studying the energy component of chemical reactions. Energy basically is something that can be used to do work or to transfer heat. Work is basically energy that's used to cause something to move. Heat is energy caused to make the temperature of an object increase. So these are the kind of the basics that we're going to be talking about. These are just kind of household terms to kind of get used to. We have kinetic and potential energy. You might remember this from your middle school science classes. Kinetic energy is the energy of motion, and it's equal to 1/2 mv squared. Potential energy is the energy of motion relative to other objects. A push or pull is considered a force, and forces are part of energy. Traditional, Newtonian physics, potential energy is mgh, where m is the mass of the object, g is the gravity constant, and h is the height. So you can imagine if I have a boulder at the top of a hill, it would contain more potential energy than a boulder at the bottom of the hill. For us, we can have electric fields, electric potential energy, which is a constant, where Q1 and Q2 are the charges in coulombs of our electric field, and D is the distance between the two fields. We'll probably focus more on a potential energy known as chemical energy, and this is energy stored within the bonds of a substance. There are a couple of units of energy to be aware of. One we'll be using quite a bit is the joule. It is the SI unit for energy. Joules is related to our Newtonian units in terms of force and acceleration and mass. But we usually, instead of using kilogram meter squared over second squared, we use joule as our unit. And remember that because it's an SI unit, we can apply prefixes to it as well. So 1 joule equals, or 1 kilojoule equals 1,000 little joules. Calories, which we see on the back of our nutrition and food labels all the time, is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. In case you have to convert from calories to joules, 1 calorie is equal to 4.184 joules. This is something to remember. If you see a calorie with a capital C, this is known as a dietary calorie, and dietary calories are actually kilocalories. So a dietary calorie is actually 1,000 little calories. The other thing to be aware with respect to energy is defining what your system and surroundings are. When we define the system and the surroundings, it helps us understand the flow of energy relative to how we're setting the boundaries. The system basically is what we're studying. The surroundings is everything outside of the system. In a closed system, energy can be exchanged, but the surroundings don't really matter. The system does not lose or gain mass. We're just talking about energy. And we're basically looking at energy exchanges for work and for heat, or energy loss or energy gain, depending upon how we're defining it. So here we have our boundary, we have our thermodynamic system and the surroundings. The white represents the boundary. If we, for instance, define our candle as our system, everything outside of the burning candle would be considered the surroundings, and we could define energy flow depending on how we define those things, of course. And we'll talk more about this in class in terms of understanding energy flow and signs and conventions and stuff. Other things in terms of transferring energy, work, and heat. Energy that's used for work is used to cause an object to move. Work, and this is something you'll see again in physics at some point, equals force times distance. If an object is the system, the work performed on the system means that the energy is transferred to it. Okay, so that means that you're doing work on the system, okay, as opposed to the system doing work for the surroundings. Heat is basically energy transferred. It always goes from hot objects to colder objects. Energy transferred between the system and surroundings as a result of their difference in temperature, and heat is transferred from the hotter system to the cooler surroundings. So there's no such thing as an increase in cold or feeling cold. There's either heat or an absence of heat, and if there is heat present, it will search and kind of look to cooler areas to kind of move towards. Kind of like the same way aromas diffuse, same general concept. And until next time.